Hello everyone, welcome to my YouTube channel. I am Chandana, pursuing Bachelor of Engineering in Electronics and Communication from Sri Venkateshwara College of Engineering. Subject Applied Physics for Triple E stream, and today I am going to discuss about the topic Lorentz field and Clausius Mossotti equation. So let us look into the table of contents. Definition for Lorentz field and the formula of Lorentz field, applications of Lorentz field, and definition for Clausius Mossotti equation and derivation for Clausius Mossotti equation and the applications of Clausius Mossotti equation and the conclusion part. Lorentz field. Internal fields in solids. When dielectric material subjected to an external electric field, each atom develops a dipole moment and acts as electric dipole. Hence, the field at any given atom will be resultant of the applied electric field and the electric field due to the surrounding dipoles. The internal field is the electric field that acts at the site of any atom of the solid subjected to an external electric field and is the resultant of the applied field and the field due to all the surrounding dipoles. So in one dimension, the internal field is given by EI is equal to E applied plus E dipoles. EI is equal to E plus 1.2 alpha E divided by pi epsilon naught d cube, and here EI is internal field and E is electric field, alpha E is electronic polarization and E is electric field, epsilon naught permittivity and d cube is separation. In three-dimension case, EI is equal to E plus gamma epsilon naught P, where gamma is equal to internal field constant and P is polarization. For 3D, the internal field is called Lorentz field and is given by the equation E Lorentz is equal to E plus P divided by 3 epsilon naught. E is electric field, P is polarization, and where the gamma is equal to 1 by 3 if the lattice is cubic lattice. So the above equation is called Lorentz relation. So it is the handwritten formula. Applications of Lorentz forces in everyday life, speakers and microphones. So when we listen to the music on our phones, so the sound you heard that was created by the interaction between magnets and the electric currents in the speaker and electric generator. Electricity that powers your home is generated by the spinning turbines equipped with the magnets and that interacts with the coils of wires using the Lorentz forces to produce electricity and scientific technologies. So these are the applications of Lorentz fields. Clausius Mossotti equation. So this is the derivation of Clausius Mossotti equation. Considered a solid dielectric material with dielectric constant epsilon r if n is the number of atoms per unit volume and mu is the dipole moment of the atom in the material. Dipole moment per unit volume is equal to n mu. Equation number 1. The field experienced by the atom is an internal field EI and alpha is electronic polarizability and mu is equal to alpha EEI. Equation number 2. Dipole moment per unit volume is equal to n alpha EEI. Equation number 3. Dipole moment per unit volume is nothing but polarization P. So I just move to the handwritten. So this is the derivation of Clausius Mossotti equation. N is equal to number of dipoles per unit value. Mu is equal to dipole moment. Mu is equal to alpha EEI. Alpha is electronic polarization. Dipole moment per unit volume is equal to N alpha EEI. Equation number 1. And polarization P is represented as polarization. P is equal to N alpha EEI. Equation number 2. And when we rearrange this equation, EI is equal to P divided by N alpha E, that is equation number 3. The formula for polarization P is equal to epsilon naught epsilon r minus 1 E. When we rearrange it, E is equal to P divided by epsilon naught epsilon r minus 1. Equation number 4. And EI is equal to E plus gamma P divided by epsilon naught. Equation number 5. So when we equate this equation number 4 and 5 in equation number 3, we will get P divided by N alpha E is equal to P divided by epsilon naught epsilon r minus 1 plus gamma P divided by epsilon naught. So when we simplify it further, we will get 1 divided by n alpha e is equal to 1 divided by epsilon naught into 1 divided by epsilon r minus 1 plus gamma. So when we do further simplification, we will get 1 divided by n alpha e is equal to 1 divided by epsilon naught into 1 divided by epsilon r minus 1 plus 1 by 3. So the gamma is substituted as 1 by 3 because of cubic lattice. Um, and for the simplification, when we do the LCM of this part, we will get 1 divided by epsilon naught into 3 plus epsilon r minus 1 divided by 3 into epsilon r minus 1. And finally, we will get 1 divided by n alpha e is equal to 1 divided by 3 epsilon naught into epsilon r plus 2 divided by epsilon r minus 1. So further simplification, 3 epsilon naught divided by n alpha e is equal to epsilon r plus 2 divided by epsilon r minus 1. When we do the reciprocal of this equation, we will get n alpha e divided by 3 epsilon naught is equal to epsilon r minus 1 divided by epsilon r plus 2. So this is the formula of Clausius-Mossotti equation. Applications of Clausius-Mossotti equation. This equation may be employed as a useful interpolation scheme when computing dispersion properties of optical fibers, particularly for structures having multi-component regions or graded compositional profiles. This relation connects the relative permittivity of a dielectric to the polarizability of the atoms or molecules constituting the dielectric. Thank you for watching. Please do like, share and subscribe to my channel. Once again, thank you.